So last week, you guys worked on this for 2 different days, and I think it's important that we go through it to make sure that, number one, you got the right answers, and number two, you have a great foundation, because when we start talking about this more in depth over the next 2 weeks, that a lot of this is just going to be repetition. You're like, I already know that, and that's going to be good things, because once you know it, then I don't have to go back and constantly reteach. So the way that I figured out how to use these worksheets is it builds a foundation. So instead of me standing up here and lecturing in front of you of something that you've never ever seen before, you've heard these words, you've seen these words, you understand kind of what some of the things are. Jamila, can you get in? Go ahead, please. Okay. So the first thing we need to talk about is this right here. This word. When you see the word molecular, don't shut it. What word do you need to connect to that? Covalent. Very good. Covalent. Okay. So let's even add an extension to that, because I know you guys wrote that, but covalent. What's happening to the electrons in this thing? Very good. They're being shared. So we've got some shared electrons. Now, there's 2 different types of sharing that occur. What are the 2 types? Polar and nonpolar. Very good. So you got equal and unequal sharing of electrons going on. Now, the one other word that I want you to go back and put somewhere on all of this to connect it, that's really the concrete thing, is that we need to talk about this word right here. Prefixes. So when we're talking about molecules and covalent compounds, will you have prefixes on the names? Yes. Hopefully you guys got to the ionic part as well. Were there any prefixes in ionic compounds? No. And that's going to be the number one thing that's most missed by students. And let me give you a prime example. So I've got two chemical compounds here. Do you agree that those are 2 totally different compounds? Do they look fairly similar? Yes. What's the only difference in terms of the elements that are present? Nitrogen and lithium. So here's my first question to you. And just do it by raising your hand. How many of you know without a shadow of a doubt, 100%, which one of these is covalent? That's scary. Okay. All right, well, let's do this. Let me ask this question. When we have covalent bonds, what 2 things bond when it's covalent? Okay, so we got 2 non-metals. So the second thing is we have ionic. When you have an ionic bond, what 2 things bond? All right, so now that we have refreshed these 2 things. So a covalent bond is 2 nonmetals. An ionic bond is a metal and a nonmetal. So now let me ask that exact same questions again just by showing your hands. Do you know within 100% which one of these is a covalent molecule? Okay, I'm going to pick on people without their hands raised. Michaela. You know, which one is it? Remember? Okay, that is the covalent one. But tell me why, Michaela. Okay, they're 2 nonmetals. All right. Now, so this other one, how would you have known how to completely flip the question? And this is for everyone. How did you know that Li2O was ionic? Lithium is a metal, so this is going to be ionic. So here's the differences. Within covalent, we're going to have some prefixes. Now, I'm going to go ahead and throw one of those little curveballs at you. And again, remember those Velcro things? You're going to have to pull this back later. There's only one instance when an ionic compound will have prefixes, and that's if a polyatomic is present. Because you guys remember when we did like hypochlorite and hyperchlorate and stuff like that? That is what I mean by there may be some of those prefixes, like dimercury or things of that nature. But for most instances, you're not going to have the prefixes. There's a few that will show up, but not many. Okay. Yes. Now, so there's also something else that you guys learned in terms of what the numbers are. So just throwing this out, what is the prefix for the number 1? Mono. What about the number 4? Tetra. Tetra, in this case, is tetra. What about 6? Hexa. 7. Hepta. All right? Now, so whenever we talk about the prefixes, there was a special rule for the first element. When did the first element get a prefix? Does it always get a prefix? No, the prefix only got the first element only got a prefix if the subscript was more than 1. Okay, so what would the prefix be on this first element? Die. Very good. So we know that it's going to be die. Now the second question is, do you change any of the other part of the name of the first element? Of the first one? No. So what is the first part of this? Okay, very good. So we got dinitrogen. Now the second question. When does the second element have a prefix? Always. You will always put a prefix on the second element. So my question is, what is the subscript of oxygen? What's the subscript? It's understood to be a 1. What is the prefix for 1? You've already answered that. Mon or mono. So here's the deal. And this is where it gets a little weird. And we've talked about this in class. Remember we had this little vowel issue. And we'll get to this a little bit later on. But the reason that I see this a lot, and it'll make sense when you see it, do you see a difference? Does one of them look right? The red one looks right. But if you read the orange, I don't even know how you would read that. Is it monoxide? Is it monoxide? So there becomes a point in which we have to really pay attention to the vowel endings. Okay. Now over here in ionic, remember we never have prefixes. So what is this Li? It's just lithium. Now again, why will it not be lithium monoxide? This is the key right here, and I'm telling you right now. I know this class well enough to know that that's going to be your number one issue, is that you, as a group, are not going to pay attention to the differences between ionic and covalent. I'm telling you right now. So you are going to miss problems because you chose the wrong naming system for the wrong compound. You're going to get them mixed up. You're going to try to do both in the same compound, and you can't. The only way to get good at this is to pay attention to exactly what's going on and knowing whether it's a covalent compound or knowing whether it's an ionic compound. And what have I told you from the beginning? If it's ionic, what do you not have? Prefixes. So this is going to just be lithium oxide. And we'll talk about the ionic aspect tomorrow, but I want to go through the covalent part of it today. One other thing about this vowel issue, and I want to bring this up, is let's say we have this. Which one of those is the correct version? The first one or the second one? That's the correct version. Now, I agree. Some people say the second one doesn't even look right. And I agree, it kind of looks a little funny. Tetroxide to me doesn't look as okay as tetroxide. However, there is a rule, and some of you know the rule. We've discussed it a little bit. But this is one of the things that you kind of have to pay attention to, how important it is to notice those things. Now, there's one other little weird part about the AO thing that we need to also mention, and it has to do with the eyes. Now, which one of those is correct? The top one. And you've been saying carbon dioxide since you were probably in the 2nd or 3rd grade. That's just been a part of your repetition of vocabulary. So you know that it's dioxide. But if you follow the rule from previous, which is if it's a vowel, touching a vowel, you drop one of them. But why do we have to leave the I here? Okay? Because if you get rid of the I, you lose the functionality of the prefix. Such as, what's the other prefix with an I? Tri. So same thing, if it were trioxide, you would not call it troxide. It's trioxide. So you need to, if you got an I, leave the I. So don't ever drop the I off the end of it. And again, it's just di and tri. So write them as they are. All right, so let's actually get into answering some of these questions. Okay. So the first one. There was something I wanted to write up here. What was that? I read it earlier. Yeah. It may come to me just a minute, but there was something else I was going to write up here. All right, so the first thing is we want to know the number of atoms on the first element. So we're talking about all of these things right here. Now, most of them, so how many Cl's do you have present? One. And then how many F's do we have present? One. They did that one for us. What about C here? Oxygen. One. C in the next one. And then two oxygens. How many chlorines? Two and one. And then what's the next one? 1 and 5, and the last one is 2 and 5. Now, so they're kind of building you. They're getting you ready to be able to answer some of these questions, but the thing that I want to jump in and talk about is the naming system. Over here in the very last column where it says the name of the compound, how many rows, and you have to look at it, how many rows have a prefix on the first name? What are those two? All right. Dichlorine and dinitrogen. So if you look over here in the second column where we wrote all these numbers, what do you notice that's different about those two rows as compared to the rest of them? They have more than one. So if you go back and you look at it, all the ones that have a 1 in that first column, God bless you, they do not have prefixes on their first elements. Okay. There's something else that I want you to also notice. Look at the ending to all of these first names. What do you notice about the endings here and the endings on the periodic table? They're the same. Okay. So if you notice, did any of the name ending changes on any of those first words? No. Now here's my next question. What do you notice about this one, and that one in terms of their similarities? They're all ones. But look at that second word. What do all of them have? They've all got mono. Again, I keep saying these things. I know you're tired of hearing them, but I can assure you that someone in this room is going to mess this up. It happens every single year. Again, one more time. When does the first element have a prefix? When it's more than one. When does the second one have a prefix? Always. Now the last part, thank you, sir, that I need to ask is look at the ending on all of these. What do you notice about the ending on every single one of these second words? It all ends in I. So if you notice, there's an ending change on only the second word. So make sure that as we're going through this, you catch all of those things. It's the simplest thing to do, but it's the easiest thing to mess up if you're not paying attention. Okay? All right, so number 1, we've already done that. Number 2, examine how many molecules given in Model 1 for the various molecule compounds. So A, how many different elements are present in each compound shown? 2. Make sure you have a 2 for that one. Number B, what do compounds combine with? Metals and metals, metals with nonmetals, or nonmetals with nonmetals? Non with non. So make sure for B, you've got non with non. And again, the key part here is do the compound, well, I guess it would be molecules. All right, so C, based on your answer to B, what type of bonding must be involved in molecular compounds? Covalent, fantastic. And again, that's going to be a key to the rest of this. All right, so number 3, find all of the compounds in Model 1 that have chlorine and fluorine in them. Explain why the name chlorine fluoride is not sufficient to identify a specific compound. So let's go back up. How many up here have chlorine and fluorine in them? The first 2. So let's look at these 2 right here. So listen to the way I ask this question. Look at the very first word in both of those answers. Is there a difference in either of the first words? No. So far, chlorine fluoride's okay. But then what becomes the major difference in the second word? The prefixes. So we went from mono to penta. So why would monofluoride not be appropriate? But that's mono. But this specifically says, why would chlorine fluoride not be sufficient to identify a specific compound? Thank you, Jamila. It doesn't tell you And I want you to write this in some way, shape, form, or fashion if you don't have it like this. It does not tell you exactly how many of each atom are present. Got that, Brett? You sure? Did you write that down? It will. Element. How many of each element are present? Because if you look at chlorine monofluoride, that tells you how many fluorines are present. How many? If chlorine pentafluoride tells you there are 5. Well, if you left off the prefix on the second word, you have no clue how many are present. Okay. All right, so number 4. Assuming that the name of a compound gives a clues to its molecular formula, predict how many atoms each of these prefixes indicates. You should already know this. Monoamines, diamines, and pentamines. Now, this is a genuine curiosity question. How many of you knew all 3 of those before you started doing this? Okay. So let's move on to the next one. Every year, these 3 always get mixed up. Come on. And I don't know why, but those 3 that I just wrote are always the ones that are most missed. The best way that I can remember hexa is they have X's, so make the X's match. Hepta is either left off or just completely forgotten, and nona, for some reason, is also left off. Okay. Most people get 1 through 4 right. Those are pretty simple. People understand 8 and 10. Those are pretty simple. But those 3 right there that I just wrote always get misinterpreted. Okay? So everybody good with that? So please don't mess those up. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. All right, so number 5. We just did that. So number 6. What suffix ending do all of the compound names in Model 2 have in common? "-ide". So right here, number 6 should be "-ide". Real quick, just kind of pointing this out. What is this out beside the number 7? So what does that mean? It's really important. It's going to unlock some information for you. Carefully examine the names of the compounds of Model 2. When is a prefix not used in front of the name of an element? Now, there's a little trick to that, because I don't necessarily like how probably some of you wrote that, and this is fine. So here's how I want you to adjust it. So the key there is that first little part in front of the dots. If you did not put that, please make sure you write that. Only on the first name. Because when does the second element have a prefix? Carefully examine the names. When is a prefix not used? Only on the first one when the subscript is 1. Does that make sense? Okay, so if you didn't write it like that, you need to make sure that you have it this way. All right, number 8. Consider the compound NO. What 2 elements are that? Nitrogen and oxygen. Which element, nitrogen or oxygen, would require a prefix in the molecule name? Oxygen. Why? Okay, so we have oxygen because the second element always has a prefix. Oxygen, because the second element always has a prefix. So now they've given us the task of naming this thing. So will there be a prefix on the end? On the end? No. So what do you write? Nitrogen. Okay? And now you've already told me that the oxygen needs a prefix. And what is the subscript of that oxygen? What's the subscript? Is a 1. What is the prefix for 1? Mono. Now again, we've already kind of talked about this. What do we do with that O thing? Drop it. Now the only part about this particular problem I did not like is because they have not taught you that concept yet. So that's something that we would have to kind of talk about before you did it. So this is nitrogen monoxide. Did everyone get that correct? Good. Okay. All right, so let's move down to number 9. Find the 2 compounds in Model 2 that contain a subscript of 4. A. List the formulas and names. Somebody's got to help me out. What's one of them? All right, so N2O4, which is dinitrogen. Tetroxide. All right, that's right. And what's the other one? Give me the formula. P4O10. All right, so we've got tetra. Phosphorus, that's right. And so, B, what is the difference about the spelling of the meaning, or excuse me, the prefix meaning 4 in these 2 names? So if you look at it right here, we've got this, and then we've got this. So what is different? One of them kept the A and one of them dropped the A. Which one of them dropped the A? The one that had an element that started with a vowel. Okay, so that's going to be the key difference. Say it again. Element starting with, that's a W, with vowels. Drop the A on the prefix. Now, so let's think about this out loud for just a second. How many nonmetals begin with a vowel? Oxygen, arsenic, iodine, and astatine. Okay, so those are the 4. So oxygen, arsenic, iodine, and astatine. So that's going to be an element starting with a vowel. Drop the A on the prefix. Now again, I've already mentioned this once. What if this were di or tri? What would you do? Leave the I. Okay, sir. Argon is probably not ever going to be seen, but if it does show up, then yes, you would leave argon. And the reason I said that is because you remember the only 2 noble gases that make bigger bonds are krypton and xenon. You rarely see argon in this case, because one of the ones we'll do is XCF4, which is xenon hexafluoride, but we rarely see argon. But if it did, then you would follow the same rules. All right, so moving on down to number 10. All right, find the 2 compounds in Model 2 that contain the prefix mono in their names. I'm just going to scroll up to keep from having to write it to save time, which would be this one and the last one. Thank you, okay? So, again, if you notice, the biggest difference here, change the pen back to this. Is that not the exact same rule that we just found? Okay, so you've got dichlorine monoxide and then chlorine monofluoride. Again, it has to do with the vowel. If the element begins with a non-metal, then you will change it to that. Number 11, identify any remaining names in Model 2 where the prefix that do not exactly match the spelling of their own shown in the prefix table. Are there any of those? What'd you say? It's this one. It's tribromine it should be octaoxide, but it's octoxide. I don't know even how you say that. Again, some of these things are real, some of them are fake. They're just using them just for an example. So that one right there. So if you did not write that one for number 11, that is their answer. Tribromine octoxide. Tribromine octoxide. No, that is the correct spelling of it. But the question was, identify any remaining names where the prefixes that do not exactly match the spelling shown on the prefix table. And if you go back and look, it would have dropped the A from octa to match it up with oxide. Does that make sense? You sure? Like, the A here is missing over here because it begins with a vowel. What'd you say, Massimo? This one right here that I have highlighted? Yeah, oxide. What they did is just drop the A. Yes, I'm sorry, I missed that one as well. So here's another one, tetraphosphorus decoxide. All right, this one does match because if you notice, it stayed tri. So if it's di or tri, keep the I is really the way that I kind of help remember that one. I missed that other one that Ron Howard said. Everything else pretty much is there. All right, so number 12. Use your answers to questions 9 through 11 to write guidelines of how and when you modify a prefix name for a molecular compound. Come to a consensus within your group. All right. So those are the two rules. So if you have something similar to this, then you're fine. But if you don't have anything, this is the rule that you need to make sure that you know. And again, we've said it. And I can assure you that, again, someone's going to mess this up. So if the element begins with a vowel and the prefix ends in A or O, drop the prefix vowel. If you have di or tri, keep the I. So hopefully by this point you know exactly what to do. So let's look at number 13. Would the guideline you wrote for question 12 give the correct name for Ni3 as it is given in Model 2? If not, modify your guidelines. Now, because I wrote that part in red, it does give us the correct answer. Because what is the name of Ni3? Do you double I? Yes. Nitrogen triiodide. Now, and it's just like I told you in the beginning. The number one of the main things that people miss, right there, someone will put INE. They're going to forget to change it to "ide." So it's nitrogen triiodide, not iodine, iodide. That's every second element will always end in IDE. Again, but hey, listen to me, unless it's a polyatomic, and we'll talk about those later. Remember, you've memorized those, so you already know those are 8 ites or stuff like that. Everybody go with this? Okay. All right, 14. All of the compounds listed in Model 2 are binary molecular compounds. Compounds such as this crazy thing, which is methanol, and this crazy thing, which I have no idea what it is, are not binary. Now let me ask you something. Why are they not binary? What does bi mean? 2. They've got more than 2. And compounds such as NaCl or CaCl2. What are those specific types of compounds? Please do this right here. Label these two as ionic. What is the name of that first one, NaCl? Do you agree that you've known that name for several years now? But if we were learning this today, some of you would want to name that sodium monochloride, wouldn't you? Again, that's going to have to be the number one thing that you guys recognize. Is it an ionic compound or is it covalent? Because I can see why you would want to name this sodium monochloride, but that's wrong because it's ionic. So we got to make sure that we can distinguish the differences. So propose a definition for binary molecular compounds. First of all, what does bi mean? 2. Nary means name. Okay, so it's when 2, and here's the key word. That is what a binary molecular compound is when 2 different elements covalently bond. You can say that. Yeah, as a matter of fact, you could actually exchange that word for this word. And truthfully, this is actually more accurate than what I wrote. So if I were you, I would scratch out the word elements and change it to nonmetals because that technically is more accurately correct. All right, the only reason I'm going to do 15, because you should know it by this point, the only reason I'm going to do it is because it's that right there. I want to make sure that you understand the key to all of this, because this is going to be important. I'm going to change pages, and I'm going to add this. Okay? So, here's all the rules. So those are the 4 things. The first element only has a prefix when. If the subscript is more than one, how will you change the ending of the first element? You won't. When does the second element have a prefix? Always. And how do you change the ending? IDE. And I'm going to have one more little small thing. Pay attention to the double vowel rules. So if you can do these 5 things, you can name any covalent compound on the face of the planet. Any single one of them. If you follow these 5 rules. The only other thing you need to know is what are the prefix names. If you know 1 through 10, then you can do it. That's all you have to do, is memorize those 10 prefixes, which you already know 7 of them by heart, and know these 5, you can do any of them. Does this seem simple? I hope so. Because, again, covalent is the easiest. The thing that struggles the most is being able to identify if it's ionic or covalent. Those are the things we've got to work on the most, is identifying if it's ionic or covalent. All right, now, some of you were asking this question, and I completely didn't even pay attention to it when I told you not to do it. So number 16, for which of the following compounds indicates whether or not your naming rules that we just did will apply to these formulas? Which one of these will it not apply to? Very good. It will not apply to that one. Okay? This is actually an acid, and we'll get to acids later on. So who can I pick on? Anijah, will you give me the name of that first one, please, man? Again, 5 things is all you got to do. You can do 5 things. What's the prefix on the first letter? All right, well, let's talk about it out loud. Does the first element have a prefix on it? No, so what's the name? Okay, so we got phosphorus. Phosphorus. Come on. Does the second element have a prefix? What is it? Try. Okay, now what is the root element? What is Br? Bromine. But does it end in INE? What does it end in? The second element ends in... No, up there it does, but in the name. Okay, so it's phosphorus tribromide.
Yeah, I just wrote phosphorus tri.
You stop. Okay, Michaela, can I pick on you for this one? S. Does it need a prefix? No, why not? The prefix only for subscripts more than 1. Okay, so it is 1. So is sulfur. Does the second one need a prefix? What is the prefix? Tetra. Okay, now what is the element of this there? Chlorine, and it ends in ide. So it's tetrachloride. Very good. Okay. Natalie, does the first one need a prefix? Yes, and what is it? Di. Now, how does this one end? Nitrogen. Very good. Remember, we only changed the ending on the second one, so it's dinitrogen. All right, does the second one need a prefix? What is it? Di. And what does it end in? Fluoride. Very good. Massimo, the first one, does it need a prefix? No, so what is it? Sulfur. Does the second one need a prefix? What is it? Tri. Now, we've got a vowel issue, but it's di or tri. What do you do? Leave the I. So it's tri what? Very good. Trioxide, not trioxygen. Trioxide. All right, Brandon, you get the last one. Does the first one need a prefix? No. What is it then? Bromine. Does the second one need a prefix? Yes. When does the second one need a prefix? Always. What is the prefix for that one? Mono. Very good. And what is it in mono what? Fluoride. Very good. All right, Jalen. Disulfur decafluoride. What's my first letter and my first number? Okay, very good. And then what about the next one? Very good. Tristan, carbon tetrachloride. You have a question? Go ahead. Say it again. Hang on one second. Oh, my bad. Okay, go ahead. Yes. The A. You would drop the A. So it's tetroxide. Yes. Does that help? Okay. All right, Tristan, carbon tetrachloride. What you got? Very good. CCl4. Okay. Lily, oxygen difluoride. Very good. Bailey, dinitrogen trioxide. Very good. And Blaze, tetraphosphorus heptasulfide. Very good. P4S7. So is this easy or hard? This should be easy, guys. These are the easiest ones you can do. So if you see prefixes or covalent compounds, you should not miss any of them. All right, tomorrow we'll pick up here because this is going to start talking about your ionic compounds.